So remember, a z-score represents a number of standard deviations, and down here I had mentioned a couple of z-scores. I have a z-score of -1 there, and I have a z-score of +1 there. And there's a few ways to think about a z-score. The first thing about a z-score is it just counts standard deviations from the mean. So in the example I was looking at for hours of sleep, we knew that the mean was about 7, and the standard deviation was about 1.3. If an individual, call them X, has hours of sleep of 9, we want to count 9 is how many standard deviations away from 7, because the z-score counts that. Well, we have to look how far are 9 and 7 apart. So X minus X bar, so 9, take away 7, it tells me that they are 2 apart. So that's more than 1 standard deviation. So I can see right away this person has a z-score that's more than 1 because they're more than 1 standard deviation away. So we take that distance and we divide it by the standard deviation to figure out how many of those standard deviations is that distance, that difference. So in this case, we divide that by 1.3. Whip out a calculator. And according to Google, it's going to be about go to 2 decimal places, 1.54 for that z-score. So for this mean and standard deviation, hours of sleep of 9 has a z-score of about 1.54, or 1.54 standard deviations away from mean. And this is, again, just a way of ranking a particular value in a data set. So z-scores are also a measure of rank. Like percentiles are. Just a different way to take a look at it.